Hello friends, this is Anshu Srivastav. Welcome to Never Stop Learning platform. I hope you are doing best in your life. Today we are going to start one interesting topic, and the name of that topic is electronics transformer. I hope in your life you are already aware what is transformer. If you see, as an engineering background, there are two types of transformer. One is the electrical transformer, which is used in your substation, and other transformer we are talking about the electronics transformer, which is basically related for electronics domain. So in this session we are going to discuss about the electronics transformer, and later in another session we will also plan to discuss about electrical transformer. So let's have a look about the transformer. So transformer is a static device that transform alternating current electrical energy between two or more circuit through electromagnetics induction. Means, first of all, if anybody asks you what do you mean by transformer, you just say in that way that it is a static device which transform energy from one circuit to another circuit through electromagnetics induction. So its primary purpose is to increase, step up or decrease, step down voltage and currents level without changing the frequency. So here the three figures are there. One is your actual transformer. If you see, it has primary winding as well as secondary windings, and these are the laminated strips E and I, which combines to make a transformer. And the another figure is the structure of this transformer, how the primary winding is connected with the AC voltage source, and how the induced EMF, we call it flux, induced here on the laminated core, and after that the secondary winding is connected with the load. And the another figure, the last one, it is the same primary voltage apply in the primary winding, secondary voltage develop across the secondary windings, and there is a magnetic core, and this is the another symbol of Vp and Vs. So let's understand about the transformer structure. The two coils windings are not electrically connected but are only linked magnetically. A single phase transformer can operate to either increase or decrease the voltage applied to the primary winding. If you see the structure, it is again the primary coils, secondary coils, Vp applied across the primary winding, and Vs is from the secondary windings, and there is number of turns in the primary winding is denoted by Np, and the secondary windings turns is denoted by Ns. So Vp is your primary voltage, Vs is your secondary voltage, Np is the number of primary windings, and Ns is the number of secondary windings, and phi is the flux linking the windings. And there is one important relations of the voltage with respect to number of turns in the windings, primary with respect to secondary. So Vp upon Vs is equals to Np upon Ns. And if you see the other diagrams which is nearby with this transformer, it is the E and I section inverted on alternate layers, I section and E section. Each individual lamina insulated with lacquer or metal oxide, and the primary winding is there, secondary winding is there, and a former. So laminated soft iron core clamped with bolt insulating cover. Okay. So one more thing I would like to add on here, that if the number of primary winding is greater than the number of secondary windings, then it is called the step down transformer. And if the secondary windings turns is greater than the primary windings turns, then it is called the step up transformer. Okay. So now let's know about the working principles of transformer. This is the same figure what we expect earlier. We apply the alternating voltage across the primary windings. Transformer core is there, or we call laminated core, and the secondary voltage, there is a load. Here it is a bulb act as a load connected across the secondary windings. So the circuit is closed here, and flux is also induced in the laminated core. So the transformer, there is no direct electrical connections between the two coils windings, thereby giving it a name called uh, called an isolation transformer. Generally, the primary winding of the transformer is connected to the input voltage supply and converts or transform the electrical power into the magnetic field, while the job of the secondary winding is to convert this alternating magnetic field into electrical power, producing the required output voltage. So if you see the another figure, we have applied the alternating source across the primary windings. The first coil, the flux induced in the primary winding. Secondly, if you see, the secondary winding is also linked with this laminated core, transformer core, and again the flux is generated from this secondary coils, and the induced voltage is developed across the V2. Transformer works on the principles of the Faraday law of mutual electromagnetic inductions. The Faraday law states that when a conductor is placed in varying magnetic field, an electromagnetic force is induced. A closed conductor circuit induces a current. This is the induced current. The magnetic field can be variable due to the various reasons, such as the conductor moves in and out of the magnetic field, and the magnetic field is not static, it keeps changing in the direction and intensity called magnetic flux. Faraday's second law states that induced EMF in a coil is equal to the rate of change of flux linkage. So the types of transformer, just now we read that the step up transformer and step down transformer. Just compare both the windings here. If you see the primary step down transformer, the primary windings number of turns is more than the secondary coils turns, and if you see the step up transformer, the primary windings turns is lesser than the secondary windings turns. Okay, so when a transformer is used to increase the voltage on its secondary windings with respect to the primary, it is called a step up transformer. And when it is used to decrease the voltage on the secondary windings with respect to the primary, it is called step down transformer. Now suppose if we apply 220 volt AC 50 Hertz across the primary windings, then let's give an examples that we are achieving 24 volt AC across the secondary windings. So 24 volt is lesser than 220 volt, right? AC. So we can say it's a step down transformer. Now there is one interesting part. What are eddy current? The alternating current AC is a sinusoidal signals which makes half cycles of positive and half cycles of negative. Okay, so constantly changes directions and magnitude. Changing magnetic field drives the transformer operation, and swirls induce small circular electrical currents, eddies, inside the solid metal core. If you see this diagram, so it is mentioned eddy currents inside the solid metal core. So the eddy current leads to energy loss in the transformer. The eddy currents are the primary cause of energy loss as heat in electrical transformer. Some currents swirls within the iron core creating eddy current. These current leads to energy loss. To minimize this wastage, engineers laminate the iron core, which significantly reduces the eddy current and improves overall efficiency. Why do they cause energy loss? Resistance: the metal core has electrical resistance. Heat generation: moving currents generates heat I square into R. And reduced efficiency: the energy turns into waste heat instead of transforming to the load. And how to eliminate the eddy current? By core lamination. Instead of one solid block of iron, the core is built using thin stacked sheet lamination. Breaks the path. The sheets are coated with insulating varnish, restricting flow. This confines eddy currents to tiny loop within each sheet. Using high resistivity materials, silicon steels, cores are often made of silicon steel. Lower currents: this specific material increase electrical resistance naturally, lowering the magnitudes of current. Now we discuss about the applications of transformer, where it is used in the market and what are the applications are there. Changing electrical voltage, we just understand what is step up and step down transformer. Power supply, of course, it is used in power supply, and there is a center tap also in the secondary windings from where you can achieve multiple voltage across the secondary windings, like 24 volt AC, then 12 volt AC, after that 10, 6, 4, 2, whatever. Okay. Then current conversions, impedance matching, isolation, audio transformer, Tesla coils, medical usage, railway electrification, backup power system, voltage stabilization, arc furnace, applications of transformer in power generation, transmission and distribution, lighting, and telecommunication. Guys, thank you very much for your time that you are available on this session. And believe me, Never Stop Learning channels are very popular in this time. Multiple viewers are joining and gets the knowledge from this channel, and I'm very gladful all of them who come and watch my channels, and also put your comment so that we will improve our channel and we will sort out what we can do best for all of you. Thank you very much. Please subscribe my channel. Again, take care and do something special in your life to get internal happiness. Thank you, guys. Bye.